All right, today we're going to talk about section 3.1, going past CPCTC. We're going to talk about what it is to have a median and altitudes in triangles, and talk about how, what is auxiliary lines and how to use auxiliary lines, and using those in proofs. Before we talk about the proofs, we need to talk about what is a median of a triangle. And in this diagram here, we have three of the same triangle drawn to emphasize that there are three medians in a triangle, and a median of a triangle is a segment drawn from the vertex. So in this case, we have A as the vertex, and it is drawn to the midpoint of the opposite side. So it divides that segment into two congruent segments. And there are three separate medians because we could draw it from vertex A. We could also draw it from vertex B down to the midpoint, dividing it into two congruent segments. And we also have a median from vertex C. So there are three medians within each triangle. The same could be true for an altitude. Again, it goes from the vertex of a triangle, and it goes to the opposite side, but it's perpendicular to the opposite side. So therefore, it goes from the vertex of a triangle. If we go to the middle triangle here, we have the vertex of B. It's drawn to the opposite side where it is perpendicular, so it is forming right angles. Sometimes the altitudes of triangles are not within the triangle. So in the other two examples, if we look at the first triangle from vertex A, if we were to extend segment BC past, make it line BC, the altitude would actually be outside of the triangle. So the altitudes do not always have to be inside the triangle, but again, they have three altitudes because you can draw it from each vertex. Something else that we'll be adding within our proofs is talking about auxiliary lines. And for auxiliary lines, it is talking about adding in a segment. So if we had a particular diagram like this, we could draw in segment AB. Draw a line AB, we're going to use the segment. And what allows us to draw a line? If we were to have 2 points, then it would determine the line. The definition of the line means that we need 2 points. So we will be using this if we need to ever add a segment within our diagram to complete the proof. And then for medians and altitudes, the specific way we're going to talk about writing them is if-thens. The median, if a segment is a median, then it is drawn from a vertex to the opposite side, dividing the side into two congruent segments. And then in that step, we could list the two congruent segments. For altitude, we talk about, starts the same way, segment is an altitude, but if talking about drawn from a vertex to the opposite side, and this time it is forming right angles. So in that step, we could say the right angles for that proof. Now let's talk about how those would look like in proofs. Last night we talked about CPCTC. So what I like to do before talking about how to actually write out the proofs is first think about what we have in our information from our givens, and how could we get to find our information. So if we were to first start with altitude, because AD is the altitude, it's going from the vertex to the opposite side, and it would form a pair of right angles. If AD is also the median for the second given, I would know that it goes from A to D, and it divides that side into two congruent segments. If I look at my diagram now and trying to prove triangles congruent, I'm missing a piece of information, but I know that both triangles on the left side and the right side, they share the reflexive side. So I could prove that those two triangles are congruent, and then angles B and angle C are within those two triangles. So that would be the path that I'm going to take to write this proof. So how would that look? If I first start with my given information, and I'm starting with median. The reason why I'm starting with median is I'm going to try to make my proof look like the diagram. And in my diagram here, I clearly have side, angle, side. So I'm going to try to list a side first. And then I can say that the two segments are congruent using the median definition. If a segment is a median, it's drawn from the vertex to the opposite side, dividing the segment into two congruent segments. I know you guys are going to ask if there is a shortcut, and no, right now you have to write out this entire definition. So that gives me a pair of sides. Looking at my diagram, I'm going to now want to try to get angles. So I can say that it is an altitude. And the altitude definition tells me that I have two pairs of right angles. Because if it's an altitude, then it's drawn from the vertex to the opposite side, forming right angles. Now, when I'm listing to form my congruent statement, side, angle, side, the angle is a congruent statement of angles. So I still need to list that the pair of angles are congruent. And in this case, it's because two angles are right angles, then they are congruent. And that gives me my angle. And now I'm trying to get my last side, so I can say that the third side is congruent, and that is the reflexive side. I now have the necessary pieces to say the triangles are congruent. By side, angle, side, and my steps I was using were 2, 5, 6. Again, as we've talked about in class, you don't have to necessarily list it in the same order that I have listed, but you still need to have those steps in the proof. And then I can say that a pair of corresponding angles are congruent by CPCTC. Moving on to the next proof. In this next proof, we're going to have to look at remembering the auxiliary lines, that 2 points determine a line. So if we were to look at our given information, we are starting with the fact that we have those segments congruent. We also need to look at what does it mean when we have the circle. Which in this case we have a pair of radii. And then we don't even have the two separate triangles. So to say that we're proving those triangles congruent, we really need to add in a segment. So that's how our proof is going to look. If we start with our given information, we can say those two segments are congruent by given, and that gives us a side. Another side that we can say is coming from the fact that it is a circle centered at A. So we can say that our radii are congruent, which are segments AC and segment AD. And that's if circle, then radii are congruent. That gives us the second side. And then as we talked about in the diagram up here, we needed to add the segment AF. So we need to draw AF. And going back up to the top here, talking about why we get to add that. These, if they're 2 points, then they determine a line. Now that we have stated AF in our diagram, we can say that AF is congruent to AF. And that is because it is reflexive. That gives us our third side. And then we can prove that triangles are congruent to each other. Side, 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 steps 1, 3, and 5. next proof here, number 3, you guys are going to do on your own. You guys are going to do that and come to class with that tomorrow. Before we end the video though, we're going to look at number 4. We are going to solve for the perimeter here. So this one is an algebraic problem dealing with the median. So finding the perimeter of triangle ABC. First off, we know that because BD is the median, that goes from the vertex B down to the other side, forming or dividing it into 2 congruent segments. So we can set those 2 segments equal to each other. And then here we can solve for x. By factoring. And finding our 2 values for x. Now we need to take our x values and plug them in order to find the perimeter. So if we first plug in -5 and 5x plus 1, when we plug in -5, we get a side of -24, which does not work. And because the x values have to work for all of them, then we need to cross off -5. Once you go ahead and now finish plugging in 4 to find the perimeter. So when you plug in all of the measurements for x value of 4, we get that the perimeter must be 125 units. And that concludes section 3.4. Make sure you go back and finish the proof number 3. And that's it.